America has 50 stars on its flag, and this is the best one. All right, everyone, Chris here from Military Aviation History, and we're at the New England Air Museum checking out their F-104C. Yes, the Starfighter, supersonic interceptor made into a fighter bomber variant here with some really cool doodads that you don't see on other Starfighters. So this is going to be a cool episode. Big time appreciation here for NEAM, of course, the museum, for giving us this absolutely exclusive access. It's really been fantastic working for them. And if you have an aviation museum like the New England Air Museum in your vicinity, do check them out, because your patronage does keep those places alive. And once again, big thank you to also the patrons and the channel members for sponsoring Inside the Cockpit. It's 100% community funded. In my hand here, I'm holding the pitot tube that goes right into the nose of the F-104. It's been demounted here for reasons that are obvious, because there is a Super Saber right next to us. Now I'm going to put that down carefully, there we go, and talk about the front section of the Starfighter. In here we have a radar. It is the ASG-14T1 or T2. There was sort of a transitional phase with the C model with those two radar sets, and it's an old school parabola antenna, okay? So we've got basically a 20-mile, nautical mile range on your search mode with a conical arc of roughly 40-45 degrees. The way this works is basically you have ground control telling you where a bogey is, and then you're routed towards there. And once you pick it up on your search mode, you can then hone in on it and you fly at it. Basically, supposed to keep it straight in front of you, because eventually you go into track mode where the angle changes to a 20-degree conical angle with a 10 nautical mile range. There's also a ECM homing mode in here where you then just look out for any sort of radar signature that is out there, and then you can fly towards it. Now, this radar set, together with the IR detector that's up here, as well as the radar gun sight, is what a manual refers to a well-integrated guidance system with a high kill probability for the time. Now, in order to get to the other side of the aircraft, we will have to do some yoga, so follow me, and then we'll talk about some of the doodads that we find here. Well, now we have a guiding vane up front. Of course, there are oxygen bottles around the cockpit as well for the pilot, pressurized cockpit. And we have a 0 elevation ejection seat, but not a 0-0 ejection seat. So 0 elevation, you can eject basically at ground level. And yes, this is the one that does fire upwards of the Starfighters. But you do have to go 120 knots minimum for safe exit of the aircraft with your ejection seat. Behind all of that, well, of course, we have some antennas above and below the aircraft as well. You have TACAN, UHF, FM antennas, and so on and so forth. But behind the cockpit itself, we have the electronic compartments that are here, where some of the, well, old school computers and electronics are mounted as well. And the RAM air turbine here for our emergency hydraulic power is installed right here. That would just go out, and then there's a little turbine that would provide that power with the airflow. Nose wheel steering as well. The nose wheel does retract forward, and we're all good there on the front section. Working our way to the back, then let's talk about the engine of the aircraft. We have a J79-7A on board, and it provides 14,000 pounds of thrust in military, and we go all the way up to roughly 19,000 in afterburner. Now, it does have a shock cone, but there is no sort of variable shock cone here. The variable intake is done via guiding vanes and the compressor blades, or 6 guiding vanes that are straight in front of the compressor that then route the air into the actual engine. And there's also a secondary bypass that is used for some cooling, and that air then meets the exhaust air down at the exhaust nozzle. Moving a little bit further back, of course, the engine also has hydraulic pumps, so we have system number 1 and system number 2. System number 1 does utility stuff like, for example, the gear or the flaps or any sort of hydraulical device. and system number 2 does the flight control system. Now there's no third redundancy built in place, it's just those two. And we do also have 2 electrical generators producing power for the aircraft, as well as rectifiers for AC to DC power, depending on the system that is installed inside the aircraft. Then inside the aircraft, we have 3 to 5 fuel tanks, depending on how you want to count them. The front one, 900 pounds. The main one, 3,100 pounds. And then the aft tanks, there's actually 3 cells, which is why I said 3 to 5, right? But they count as one tank, 1,900 pounds of fuel there. Then we come to the wing. And yes, the stories are true. This is incredibly sharp, especially if you hit it with some force, as many ground maintenance crewmen of starfighters will attest. And also, every time that you go to a museum that actually has one of these starfighters, talk with some of the docents and the volunteers there who do some maintenance, and they will have some stories to tell as well. Because, well, over here at NEAM, I've actually talked with at least one person who has a scar on their hand because, well, you know, this wing. It's it's incredibly sharp, incredibly thin, low aspect and heat relay angle, and a maneuvering flap installed here in the front section on the leading edge as well. Looping around now, around this wing tank, I'm going to talk about the wing tank briefly. It occupies the wing tip position, where you could also otherwise mount an IR tracking missile. And in this configuration right here, you would have an additionally 1,100 pounds of fuel. Now, stepping around, we're going to talk about the control system. It does feature irreversible controls, hydraulically operated on the aileron, quite a small aileron as well, but it is a small wing as well. And there's artificial feel as well. The aircraft also features the stability augmentation control system, where small dampeners are in play that automatically adjust the deflection of the ailerons in order to guarantee a more stable flight. Now that we've done the aileron, let's talk about the flaps. Now, the flaps on the Starfighter are really cool. They're blown flaps, which means that bleed air from the compressor is siphoned off, and as it is then fully deflected, this air flows over the surface of the flap downwards, and it almost is as if it grabs the air that is above it on the boundary layer and makes sure that it stays attached to the flap. And as such, you don't have that airflow separation, and that allows you to achieve lower landing speeds with the Starfighter. Moving then towards the tail section, we have the speed brake right here. We have a arrestor hook down there. And then as we come to the rear, we of course also have drag chute provisions, and then we have the variable nozzle exhaust that sits right here. Now, the engine on the Starfighter was a little bit problematic, and if you look at the accidents rates and also at the rates of problems with these engines in terms of flight hours compared to all the other engines that America has built at the time, this one shines out as the one that has the most mishaps or incidents in terms of flight hours. And that is also one of the reasons why the Starfighter has that mixed reputation of, you know, being at the receiving end of quite a few accidents, because the engine, there were some issues there, but eventually those were fixed. Now let's talk about the tail then. We have a large vertical stabilizer with a rudder. The rudder, in fact, on the Starfighter features, get this, mechanical control. Yes, there is a self-centering spring in there to provide some help with the rudder, but you do have to actually mechanically manipulate it via cables. This is interesting because in the B model and the C model, which are the trainers, or for the A's and the Charlies, here the C's, you do feature hydraulic control, right? Same thing as with the aileron or the elevator, but on the actual combat version of the aircraft, it was mechanical. Then let's talk about that large one-piece horizontal stabilizer. It goes all the way from the right to the left, and it also features the automatic pitch control system, which, if the pilot is flying at, pulling too much AOA and the aircraft is about to stall, it makes an automatic adjustment to the deflection of the pitch of the elevator or the horizontal stabilizer and moves it forward, or rather nose down, so to prevent the pilot from stalling. Now then, as we move around, what a beautiful bird she is. You've got to say that. Wow. Always been a fan of the Starfighter. On the right-hand side here, on the left-hand side, we of course have the exact same setup. Remember, because of the very, very thin wing, there are no wing tanks installed in the aircraft. You only have these wingtip tanks in place of, let's talk about the armament, shall we then, as we squeeze through the aircraft with the hangar doors here. Now initially you could mount those old school AIM-9Bs on the aircraft, so the basically one of the earliest sidewinders that was out there, and those are IR homing. You have one on the left wingtip and one on the right wingtip. And then in the fighter bomber version, we see the first provisions for also then pylons. So you could carry up to 2,000 pounds of ordnance, that is bombs and rockets, but there are also special provisions for so-called special weapons, which are nukes that could be installed on the aircraft. Then with the gear, you can see that it is housed internally in the centerline position. The gear just swings forward into the gear well, which is closed off here now by the museum for demonstration purposes. And it always looks to me, at least for the Starfighter, it always looks to me as if it is very finicky and not very strong, but it's doing its job. It's doing its job, definitely. And then finally, the weight of the aircraft, as we were already talking about the gear, 12,000 pounds empty, and it goes up to 27,500 pounds fully loaded for maximum takeoff, but sort of combat weight sits more around 24,000 or 25,000 pounds. One of the final pieces in the puzzle then, we have the M61 Gatling gun. This is a 20 millimeter cannon. It fires a 20 by 102 millimeter round at 4,000 rounds a minute, or in later versions 6,000 rounds a minute, and 725 rounds are carried by the aircraft. So you do have a lot of firepower. And then as the final piece in the puzzle of this Starfighter, this is something that comes in with the sea and does provide a little bit more loiter time endurance to the aircraft. We have the refueling probe right here, used for air-to-air refueling. And with us now done on the outside of this absolutely magnificent bird, Century series of course, so many cool things come out during that time in terms of aviation history and the designs that we see, including the Super Sabre just behind it. What do you say? Shall we jump inside? Yeah, let's do it. One take! Jumping into the Starfighter, we are greeted with a typical Century series presentation. It is somewhat similar to the F-104G, the German variant of the Starfighter. You may have seen our video on this plane before, and if not, check it out, there are some differences. As always, we will go through this from the left to the right. Starting out on the far left, we have the radar and armament control panel, and then on the outer row we find the trim and stability control panel, the fuel control panel, the auxiliary trim panel, and then we move inboard, rear to front, the lighting controls, air conditioning and pitot heater controls, as well as finally the control panel for the UHF radio. Then the throttle stick, featuring an afterburner setting by moving the stick fully forward from mil power into the AB slot. The stick itself twists. If not mechanically caged, this adjusts the range setting on the side to radar ranging. The speed brake switch is on top. Next to that is the gun side cage button and the press to talk for the radio. The flap control for the aircraft is next to the stick. Alright, moving forward now. Tucked in the forward left corner we find the gear lever, as well as the landing light switches, the automatic pitch control cutout, and the starter switches to energize the ignition circuit. Moving to the upper panel then, first the left hand side, the engine inlet temperature sits here far away from the other engine gauges. Then we have a standby artificial horizon, an angle of attack meter, as well as a turn and slip indicator. Centrally, the basic flight instruments. From left to right, top to bottom, a speedometer with an integrated Mach counter, the bearing distance indicator, a gyroscopic artificial horizon, followed in the lower row with an altimeter in feet, a directional finding course indicator, and the rate of climb meter. Then, gazing to the right, the engine dials. In a column from the top, engine RPM, then engine exhaust temperature, and the nozzle position indicator. To the right of that, again inlet temperature and the oxygen capacity indicator. Just a note for the curious here that saw this already on the left hand side, yes, it is doubled here. In the manual, this position has the fuel flow indicator, while the oil pressure indicator is normally in the oxygen indicator position as it is here. Small variation like this can exist, of course, amongst exhibits. Looking upwards, we find the whiskey compass and the currently unoccupied position for the optical gun sight. Though working similarly to older gun sights, so it's not a complete HUD as you know it from nowadays, this sight also adds some visual indicators for missile employment. Okay, now look down. Still forward, but set below the main instruments. The flap and gear position indicators, a clock and fuel flow indicator are to their right, and here we would usually find the accelerometer, at least per the manual. The radar scope is just behind the stick. Its contrast cover is not installed right now. There is a small hydraulic pressure indicator flanking it to the right. And then we have left to right, top to bottom, the cabin altimeter for pressurization, the internal fuel gauge, the oil gauge, and the external fuel gauge. A small switch below it allows you to select between the tip and pylon tanks on the external bags. Above this, 3 yellow handles. To the left, the emergency gear release. Then we have the emergency ram air turbine and the emergency nozzle closure for the engine. Finally, tucked behind the stick, the special weapons panel. That would be for nukes. Now we move to the right. Underneath the warning panel, there is the oxygen capacity gauge and the electric generator switches. Moving towards the right side, we find the oxygen control panel, the VHF navigational control panel, the IFS system, and the associated selective identification panel. Further back, the DC-09 controls that works in conjunction with ordnance dropping, and outboard the special weapons release switch next to the red covered external tank refuel switch. And behind that, outboard, the air refueling probe light switch. As we move all the way to the back, the heading indicator control panel, and behind the circuit breakers, the damper gyro cutoffs. Then the aircraft's controls. Yaw is of course done via the rudder pedals, and roll and pitch is done via the control stick here. The stick follows a similar setup as you may have seen before. The hat switch is for trim, offset to the left, the pickle switch for bombs, and then the trigger for guns and missiles is in the conventional position. It can also activate the camera. The radar track action button is lower on the side of the stick, and then the small pinky switch is for the nose wheel steering. And that is it, the Starfighter. And that's us at the end of this episode with the F-104C Starfighter. Big thank you to the New England Air Museum for hosting us today and giving all of us access to this machine. And please also put your appreciation of the museum in the comment section. And if you do visit, just let them know we say hi. As always, I wish all of you a great day. See you in the sky, and a big thank you to all the patrons and channel members who make Inside the Cockpit possible with 100% community funding.